I'm gonna put your phone in my purse too.
Next stop, up stop. One more. The bench. The side. There you go.
It was out of control. Erasing thumbs down, everything. Top this transcript. All right, y'all. All right, sugar babies, today's date is March 17th. And you guys are about to learn how to use the properties of end behavior to analyze, describe, and graph polynomial functions, okay? Let's go ahead and commit our objective to our notebooks, please. Y'all ready to go? Oh. Now we can go. Okay, Savage, the mirror technique is not gonna work.
I got the whole thing down.
Babe, because when you reverse the image, when you do that today, you're gonna get a problem wrong, and I'm gonna teach you backwards in your mind. Bring your rump back up here. Bless the children. Come on.
Up there?
I say thank you. Up there. It's creative though. Not mad, just a little concerned. All right, y'all, let's go. All right, in behavior, turning point, local maximum, local minimum. We've already talked about all of these in a different form though. In behavior is actually the only new topic that we're talking about today. Turning point, remember at the curve where it changes directions? I didn't say turning point, I just said, where does the curve change directions? That's the same thing as the turning point, all right? And local maximum and minimum values, that's the same thing as relative maximum and relative minimums. Does that make sense? A local maximum value will be the maximum value in a certain region. We talked about these concepts yesterday. And a local minimum would be the same thing, the smallest or the lowest value of a function in a certain region on a graph, all right? All right, may I proceed? Okay. Young people, on your reference sheet, everybody has a reference sheet, right? This is a reference sheet of all of the polynomial functions that we will be discussing today, okay? And the end behaviors of them. Now, your text says that polynomial functions are classified by their degree. And what you have before you is an example of every type of polynomial through degree 5. Okay, a polynomial of degree 1 is very simply a straight line. Okay, a polynomial of degree 1 is very simply a straight line. You left your reference sheet? Here you go. Polynomial of degree 1. So that's any equation, something, something, whatever. I'll just write some arbitrary arbitrary linear function here, right? Say we had, and you can write this on your reference sheet as well. Curse word, y'all. I thought I was plugged up. Over here trying to write on the screen. It's not hooked up. All right. So that would be your good old fashioned y equals 3x plus 2, whatever. Okay. Linear function. That would be the graph of a line. Okay. This is the lowest degree polynomial, a straight line. Not a constant, but just a straight line that has a slope of more than 0. More or less than 0. Can't have a slope of 0. All right. Next type of function is a quadratic function. You all should be very familiar with these because we talked about quadratics ad nauseum during the first semester, okay? Good old-fashioned quadratic. This is actually y equals x squared, the one that you see pictured here. Good old-fashioned y equals x squared. But of course, you can have plus 3x minus 2, something like that, right? Let me write that a little bit smaller. Just giving you an example, okay? And of course, you can be missing terms, things can be missing, but the only thing that would not be missing is that highest degree, right? Okay? But this one's actually looks like the perfect quadratic function. A cubic function has the highest degree of 3. And that'll be a good old fashioned, and you all saw a lot of cubic functions when I was teaching you guys how to determine the roots of a cubic function by using the synthetic division. You know, figuring out if it's a root, if you have a remainder of 0. That's when you all saw a lot of these cubic functions. So that'll be your y equals 2x cubed minus 3x squared plus x minus 4, whatever. Okay, but the highest degree is 3. That will be a cubic function. And look at how it's shaped. Okay, look at how it's shaped. All cubic functions will take on that general shape. Okay, it'll take on that general shape. And the next one, we even did a few quartic functions, okay, when you all were trying to find the roots and develop the factors of these higher degree polynomials. So that'll be, I'll write it lower so I have room. Y equals, I don't know, 2x to the 4th minus 4x cubed plus 3x squared. Y'all, I'm just making this up, minus 1. But that's a general, regular quartic function, okay? Now, we've never talked about a quintic function. Never talked about a quintic function. But you would handle a quintic function just like you would a quartic and a cubic. And for that matter, a quadratic, okay? When trying to figure out the factors of the function as well as the roots. And the quintic function has the highest degree of 5, okay? You ever heard of quintuplets? Okay, 5. Quintic function has 5 roots, has the highest degree of 5. Make sense? Okay, all right. So that'll be a good old regular y equals, I've been using 2 a lot, huh? Let's see, 4x to the 5th power. It doesn't matter what the leading coefficient is. The highest degree needs to be 5, though. 4x to the 5th power plus 3x to the 4th minus 6x cubed. I don't know. Minus 5x squared plus 3x plus 1, because that's the skinniest number I can fit right there. That's a quintic function. Okay? Quintic, highest degree is what? I can't hear you. Highest degree is what? Thank you. Highest degree is 5. Okay? Questions, concerns? What's the problem? Marianne, whatever the devil's happening on that phone. If it ain't about these graphs of polynomials, let me tell you something. You see that little pink cord? Hold on. It's important. Is this your mama? If it ain't about these here quadratics, is it involving somebody's health? Marion? Is it involving somebody's health? Then it's not important. Hey, get that phone and stretch a little pink cord so I can see that phone in my eyesight. Or you can bring it over here and put it in my purse. I got a plug back here. I'll wait. You can keep it plugged up. Come on. And where the rest of your shirt at? Come here. Marianne, you are disrupting my instructional period. Plug up that dog.
And that would be the book that you do not want to have.
About to start singing hymns over here.
Amen.
Thank you, Marion. That was a very mature decision. All right. Oh, hush.
Thank you, blessing.
Mm-hmm. All right, y'all, let's go. So we've been introduced to all of these different types of polynomials. Back in the Stone Ages, when I was in school, they referred to these as parent functions, right? And you were given the general equations of each type of function, whatever. Polynomial functions, here we go. Now, let's move into this new topic called end behavior. It's very intuitive. It's literally what you think it means. End behavior. How is your function behaving on either end? Okay? At the beginning of the function and at the end of the function. What is it doing? What is the value of the function doing? Now, the text says, end behavior is a description of the values of a function as x approaches infinity. Okay? And as x approaches negative infinity. So the question really that you're asking yourself is, what is the value of my function doing as x gets bigger and bigger and bigger? And what is the value of my function doing as x gets smaller and smaller and smaller? The end behavior. We're going to talk about it momentarily. I'm going to make this real. The degree of a function, okay? The degree and the leading coefficient of a polynomial function determine its end behavior. That's really all you need to focus on to know what a graph is doing and what it will even look like. All right, now, it is helpful when you are graphing a polynomial function to know about the end behavior of the function. And if you really want to get fancy and cute, you can focus on if they give you the zeros and if they give you the y-intercept, you can have a more accurate graph, but it doesn't have to be perfect. I'm going to show you what I mean in just a second. All right, this is the second reference on your on the sheet that I passed out to you guys. Okay, now this is the general, okay, the general end behavior for each type of polynomial function that you will encounter, and you will be asked to determine the end behavior of said function. Now, the first one, this is kind of like a grid, and different plots on the grid have different characteristics. Now, this row right here is for when your leading coefficient, okay, A, is greater than 0. Babies, what type of numbers are greater than 0? I said, what type of numbers, okay? Listen, is infinity, hold on, hold that thought. Is infinity a type of number? It's a number, but what type of numbers are greater than 0? Hold on, Michael, you said it right the first time. What type of numbers are greater than 0? Positive numbers, sugar baby.
I just said that.
Baby, you said some other stuff
I
too.
said positive.
Okay, baby, you said infinity first, and then I heard Michael say
I
positive.
said infinity, then I said
Oh, okay, baby.
I said,
I ain't got nothing for you.
and I said,
You were right.
real.
Okay, you right. I ain't got nothing for you. I ain't got nothing for you. Okay, so on your paper, I want y'all to write positive right here. And when you said positive, you were absolutely right. Blessed assurance. That baby want to be right, don't he? Oh, all right. Everybody put positive on that paper? All right. So when your leading coefficient, that means that number that's in front of the highest degreed variable. Okay, we're gonna do some examples momentarily, but that's where the leading coefficient is. When it's positive, okay, and your highest degree is odd, all right, When your highest degree is odd, let me use a highlighter instead. When your highest degree is odd, this is the nature of your end behavior. Check this out, babies. Read this. As x approaches positive infinity, I typically don't put the plus symbol here because if you just write infinity, it's automatically positive, right? As x approaches infinity, what is your graph doing? Now look, remember your leading coefficient is positive and your highest degree is odd. This is your end behavior. As x approaches positive infinity, okay, as x gets bigger and bigger and bigger, what is your graph doing? Getting bigger and bigger and bigger. Going where? To where? What number lives in heaven?
Oh, it's not.
Positive infinity, right? So as x approaches positive infinity, okay, y, the function, also approaches positive infinity. That's what that statement means. As x approaches positive infinity, p of x, the function, also approaches positive infinity. Does that make sense? Now, on the flip side of that, okay, just like x can approach, you want to know what's happening with your function as x gets bigger and bigger and bigger, and as it gets smaller and smaller and smaller. Let me change colors. So, as x approaches, what number goes this way? As x approaches negative infinity, what is your function doing? It's getting smaller. Where is it going? Yeah, it's going to hell. Somebody said hell. What number lives in hell? Negative infinity. Does that make sense? So look at the statement, guys. As x approaches negative infinity, my function also approaches negative infinity. Now, this is the case only when the leading coefficient is positive and you have an odd degree. An odd degree, your highest degree is odd. Bless the teacher. Does that make sense? All right. We're just going over the rules, okay? Now, same leading coefficient is positive. It's still positive now, but we're going to switch it up. If your highest degree is even, these are the rules for end behavior, Michael. These are the rules for end behavior. Now, look at the graph. Look at the graph here. As x approaches positive infinity, what is your graph doing? It's increasing? Be more specific. Where is it going to end? It goes up to positive infinity, right? So the statement we would write is, it's right here. As x approaches positive infinity, as x gets bigger and bigger and bigger and bigger and bigger, Emma, put your phone in your purse or mine. You just picked it up. Girl, if you don't put that phone in your purse, don't give me no lip now. That's lip. Oh, who was it? Mary, you don't think you got a friend? I sure can. If I see it with it again, I will. That man said something to you like 3, 4, 50, 11 times. All right. So as x approaches positive infinity, what is my function doing? It's also going up. So here, as x approaches positive infinity, what is my function doing? It's getting bigger, but I need for you to say it. It's not just getting bigger, it's approaching what? Positive infinity, okay? Infinity. Now, what about when I go the other direction, y'all? Let me change colors. As x gets smaller, though, what is my function doing? As x goes to negative infinity, what is my function doing? Is it? It's going up. So no matter whether I'm going to positive infinity or negative infinity, my function is still going up in both directions, isn't it? So as x approaches negative infinity, okay, my function is still approaching positive infinity. And this is the end behavior when your leading coefficient is positive and you have an even degree, okay, or your highest degree is even. All right. Okay, please note the similarities and differences. Okay, when it's odd, it starts low and then goes up, right? When it's even, both sides are pointed up, and that's when the leading coefficient is positive. Does that make sense? Okay, now let's switch gears. Now they're telling me that my leading coefficient is less than 0. Well, what type of numbers are less than 0? Negative numbers. Let's write that underneath there. Let's write negative here. When my leading coefficient of my highest degree term is negative, all right? And my highest degree is odd, okay? Highest degree is odd. Leading coefficient is negative, highest degree is odd. Just look at the picture. When it was positive, it started low and went high, right? Now it starts where? Starts high and goes low. You see? Okay? So this is when my leading coefficient is negative. So let's talk about end behavior. Look at the graph. As x gets bigger and bigger, going out to positive infinity, what is your function doing? It's going to negative infinity. Okay? Does that make sense? So make a note of the end statement or the end behavior statement here. As x approaches positive infinity, my function is approaching negative infinity. Okay? Let me switch colors. As x approaches positive infinity, look at the picture. As x approaches positive infinity, my function is approaching negative infinity. But when I switch directions and x is approaching negative infinity, what is my function doing? Be more specific. It's going to positive infinity. Okay? Thus the statement, as x approaches negative infinity, my function is approaching positive infinity. Okay? Are you all making note on your reference sheet? Hello? I hope so, because these are your notes. And what's special about your notes? Come on, somebody. All right, now remember, this is when your leading coefficient is negative and you have an odd degree. I'm sorry, I keep doing that. When your highest degree is odd. When your leading coefficient is negative and your highest degree is odd. Okay? Make sense? We're just learning the rules right now. We're about to apply it in just a second. Last one. But when your leading coefficient is negative and your highest degree is even, look at the picture. When it was, when the leading coefficient was positive, both of the ends of the graph were pointed up, right? But when it's negative, what do you notice? They both pointed down. So that means when x is approaching positive infinity, okay, what is my graph doing? It's going to negative infinity. And let me switch it around. Well, here it is. As x approaches positive infinity, the function is approaching negative infinity. You feeling it? Okay. And let me change colors. When x is approaching negative infinity, all right, what is my graph doing? It's still going to negative infinity. Still. Don't matter which way you go. You feel me? And here it is. As x approaches negative infinity, my function is also approaching negative infinity. We all right? Blur? May I proceed? Yes.
Anybody actually mark?
Go ahead. Hey, you want to use the thumbs up?
maybe one, none, one.
Heaven said, come see my
I
paper.
got three.
That's all right. You don't need no highlighter.
How you say mine?
Canada.
Look at you talking junk. You want them points. I understand. Chris.
I need my.
Hey, Chris, and I understand why. Can I print out your thing? And then I need you to, I'm gonna print out
There's
your
nothing
summary,
there.
and then you're gonna mark everything that I need to change, and I'll do it. I'll do it between today and tomorrow. All right.
Show me. Okay, which one goes with which? She highlighted the green with the green.
Do you guys want color pencils? You want some? Come get some over.
I got over half, didn't do it.
Well, you see my circle.
Which one goes?
You know I got color pencils for days.
You get color pencils right now. Well, how come we didn't have some color pencils before?
Dude,
Hey, look, she's giving you notes, guys. She's giving you, Miss Bunty and I need it. You guys have got to pay attention. Circle it. If you don't have a highlighter, circle it. Circle this. No, it's not. Look, if I've got a circle right here, I circle this, I can make a circle right there. I know that the bottom goes with the what? The right side. You know what I'm saying? That's because I averaged it out and I got about half are doing it and half aren't doing it. So then some of you are gonna ask us a question, you're gonna be the ones who didn't do what?
Didn't take notes.
Didn't take notes and didn't circle it. Where's it at?
Oh, you gonna get all your
Which
colors.
one goes with
I'm not mad at all. Yo, you can use your own aesthetic when you make your notes. Doesn't matter what colors you use, okay? You don't have to use the exact ones that I
You can
used.
circle the whole thing, look.
Oh, word?
You
Yeah,
can't circle
you
the
do what you
whole
want.
thing and expect to know which one goes.
Just
with
make sure
which.
it's contrasting, you know what I
You're
mean?
missing the concept, folks.
Honey, boom, this is not
You're missing the
Crayola.
concept. Which one
You
goes with which?
can. You trying to make you a whole pack?
Yes. Yes, you got it.
Dude, I can do like yellow.
You gonna write, you would rather write the word yellow instead of using
I
yellow?
don't see it. I don't
Elisha,
see
I'm not
it.
doing this with you.
So I understand.
I see half, don't understand.
I just color, I'm like.
Did you take notes on your paper though?
Yeah, I took.
He did. I can't read his notes.
It don't matter, as long as if he can read them hieroglyphics, it's fine. Listen. That was nice, Heaven. All right, so can we make these examples real, these rules real?
Right-hand corner, look, blue goes to the bottom.
And again, you can use
Green
whatever
to the
colors
top.
you want, y'all. Just make it match.
Did you fix it?
Now you working on your 24 pack now?
Can you tell me which one goes with which? That's what I'm saying. See, when we leave right now, you're gonna go, I don't know which one goes with which, because I didn't mark it. And then you're gonna come ask me, and I'm gonna go, you didn't take good notes. You didn't highlight it like she told you to.
All right, sugar babies, may I proceed? Okay, all right. All right. I say all right.
Now we're getting closer to 90%.
Hey.
Closer.
Hey.
We got room to improve.
Still got some people that's fighting the color
They're fighting
pencils.
the battle. It's the mental, Miss Bunty, you know as well as I do, that 6 inches is the hardest battle.
Yeah, the last 6 inches.
That's between your ears. The mental parts of it. Miss Bunty referenced it over on the wall over here to the left. It's one of the things she stands by. If you haven't ever read the wall before.
Yeah.
Well, are you talking about that one right here? Or that one right here?
Which one do you think?
Or that one?
It's a Frederick Douglass quote. His signature is covered up, but
Oh, Frederick Douglass is it?
mhm.
Ain't no way he just bored.
He said what?
Ain't no way he just.
You didn't know he what?
Nah,
I didn't hear what you said, baby.
I don't even know what I said.
Bless the children.
No, you know.
He doesn't either.
There you
Admittedly.
go. Now you got it. Now you're not gonna go, Mr. Wright, what's this mean? Oh, good job. Thank you.
Bless the children.
Miriam, thank you.
Now, may I proceed to,
We're close.
not mad at all.
So now we doing no shit. I mean, so now.
And don't give us any ideas.
I ain't getting no-
Look at him running his mouth. Hey, he gonna mess it up for everybody. Look, notebook check tomorrow. Everybody tell Savage thank you.
No.
Lord have mercy. Jamar, you don't want any color pencils? You got some? That's what's up. All right, sugar baby.
246 is. But it can be negative. David, this is not true. Please put away the phone. Because we had to stop for someone like you who didn't do this. That's, please. Bob, do you have it caught up?
What happened?
You have it caught up?
Yeah.
Yeah. But then I think we have it.
All righty.
Thanks, man.
Did y'all make it party? You made it party? That's what's up. That's what's up. All right, y'all, let's do this. So let's apply these rules, shall we? Now, for these two polynomials, it's all right. Listen, I know it looks crazy, but hush, just hush, let me teach you something, all right? Now, in the instructions, it says, identify the leading coefficient, degree, and end behavior, all right? So, step one, hold on. I want everybody to write the polynomial here. Just write it down. Write it down. Just on your notes. Just not on the reference sheet, but like literally in your notes. Okay, Michael, I want you to write this quadrilateral. I want you to write this polynomial down, please, in your notes. After you write it, we're going to label each of these items. Leading coefficient, right underneath. We're not at the point where we can abbreviate yet. I need for you to write this word down, and then later we can abbreviate, okay? Okay, leading coefficient, highest degree, and then end behavior. I always spell behavior with a U. I think I was British in my former life. All right. Think so? All right. So for the leading coefficient, the first thing we need to do is find the highest degree term. Okay. In this case, it happens to be written in descending order, so we're good. Are y'all still writing? I'm gonna wait. I don't want y'all to miss nothing. I don't want you to miss nothing. Man, you want to come closer to the board, baby? You okay? I said, no, I ain't saying nothing about your phone. I said, do you want to come closer to the board? All right, sugar baby. That was funny. All right, so the thing about, everybody got it down? All right, the thing about the leading coefficient is that it is attached to the highest degree term, all right? So what is the highest degree of this polynomial?
40.
Okay, 4. Okay, x to the 4th power, that is the term. Negative x to the 4th power is the first term because it's already written in descending order. Now, what is the coefficient? It's the leading coefficient because it's the first coefficient. That's why they call it the leading coefficient. You ever heard something called a leading lady in a movie? That's the main character, right? Or the leading man, that would be the main male, the main female, right? So the leading coefficient is the first one once it's written in descending order. Now, what is the coefficient on the highest degree term? -1. All right, I'm just going to highlight it here. All right, so my leading coefficient, let's write it down, is -1. Is my leading coefficient positive or negative? It's negative. All right, so we already know using our reference sheet, which area we need to focus on, okay? Okay, the negative side, absolutely. Now, what is the highest degree?
4.
All right, highest degree is 4. Is 4 odd or even? Okay, all right. So now I know exactly where to go on my reference sheet, don't I? Let me shimmy back. I have a leading coefficient that's negative, and I have the highest degree is even. So which one do I need to look at? Number 1, 2, 3, or 4? So I'm looking at the 4 section. That is my guide, okay, to write my end behavior. Now, it's all the answer already on there for you. As x, look at the picture. And when your leading coefficient is negative, and when your highest degree is even, both hands are pointed down, right? So whether I'm going to negative infinity or whether I'm going to positive infinity, my function is going down to negative infinity. Does that make sense? So let's write that in behavior statement, shall we? We're going to say as x approaches positive infinity. I'm not going to do the plus. I just write it infinity, y'all. My function, in this case, it's q of x. My function is approaching what? Negative infinity. I hear you, Marion. I hear you, baby. Period. Second statement, okay, because x has to go to positive infinity and it has to go to negative infinity, right? All right, second statement. As x approaches negative infinity, what is my function doing? It's approaching negative infinity as well. Boom. Done. That's my end behavior statement. Does that make sense? How we feel? As you're finishing up your end behavior statements, go ahead and write down the second polynomial on your notes if you're already done. And we're going to do the same thing. May I proceed? All right. Emma, you good? All right. Heaven, Tiffany, y'all straight? Y'all, are y'all working ahead? I love it. I love to see it. All right. You thought I was gonna fuss? No, they didn't. Y'all thought I was gonna fuss at you for working ahead on math? What? I see myself in y'all. That's what I used to do back in the day. All right. Leading coefficient. What she say? She says I'm sweet. Leading coefficient. Let's just fill it out as we write it out, okay? Leading coefficient. What is my leading coefficient here, you guys? Excuse me? My leading coefficient is 5. Oh. Remember, it's the number in front of, right? Now, is my leading coefficient positive or negative? Positive. All right. So we already know, we've already eliminated a whole half of our reference portion, right? So it's positive. So I'm only looking at the positive elements. More information is given. What is the highest degree? It's 5. Was that you, Miriam? 5. Is 5 positive? I'm sorry. Is 5 odd or even? It sure is. So going back to my reference sheet, which section of the graph am I focusing on? My leading coefficient is positive and my highest degree is odd. Number 1, that is absolutely correct. So shoot, there go the answer right there, right? But let's press on through with this end behavior statement, okay? End behavior, and pardon my handwriting, y'all. All right, now listen. We got 2 sentences to write. As x approaches positive infinity, what is my graph doing? Let me go back to the picture. Okay, starts low and goes high, right? So as x goes to positive infinity, my graph is also going to positive infinity, right? Let me write that. As x approaches positive infinity, p of x in this case, my function, is going to positive infinity. Ooh, that's ugly. Y'all, I can't get my life. I need to find my life. Bless the teacher. See, whatever, it's just gonna be what it's gonna be. It's just, listen, that's infinity, okay? All right, as x approaches negative infinity, okay? P of x is also approaching negative infinity. Make sense? Hello? That reference sheet is helpful, yes or no? That's what's up. Now, the more you do this, the less you'll need it, okay? But you got to start somewhere. May I proceed? Say no? Okay, I'll wait. What in the world? Huh? Oh, that's, hold tight. I got you.
Draw a picture. You can't draw a picture. I know you can.
Excuse me.
What do you think?
Tell me something. This went to math to art class. You know what? We can do pictures for these. Let's do pictures for these. It's cool. Y'all, taking Mr. Bright's advice. Let's draw us a little ashy graph right here. Now,
I'm sorry. I would love to see anybody draw this picture correctly.
oh, can I show him first? And then I'll give him another example.
I'm sorry.
Yeah, I'm afraid. Yeah,
You're right.
not afraid, but you know. Hey, y'all, we already know, it's cool. We already know that the leading coefficient is negative, right? And the highest degree is even. That tells you right there exactly how it's gonna look. Now, because the highest degree is 4, how many roots do I have? 4. So watch this. I'm gonna say root here, root here, root here, root here, okay? Come on. Now, because the leading coefficient is negative, are my 2 ends pointed up or my 2 ends pointed down? Pointed down. So I know exactly where to start, don't I? So watch this. It's gonna be ugly, y'all, but we some thugs, right? Up, We some math thugs. Boom. That's the general. That's the general graph of that equation. Now, it will not look exactly like it, okay? But generally speaking, a quartic function with a leading coefficient that's negative, okay, will look like that. Okay? Oh, yeah, it could.
I'm not gonna say anything, I'm just.
No.
confusing.
I'm not gonna, that is important because remember when yesterday we talked about the constant?
Yes.
I'm gonna get more particular when we do an example. It's actually on the worksheet. Do you see it on, look at numbers 15 and 16. 15 and 16 is where that'll be highlighted. Okay? All right, B. Generally speaking, these graphs are really, really ashy. Now, we will get more particular, okay, the more comfortable we get with this topic, but this is just ashy. General graphs, just an ugly sketch, okay? Now look, leading coefficient is positive, but my highest degree is odd. So my little ugly graph over here, check it out. I know how, am I gonna start down or up? Look at your reference sheet. I'm gonna start up here. Well, first of all, how many roots will I have? 1, 2, 3, 4, 5. Get them on there some kind of way. Don't know what they are. And this graph will not start up, y'all. Remember, when the leading coefficient, look at your reference sheet. When the leading coefficient is positive and the highest degree is odd, it starts down and then it ends up. Do you see a reference? So this graph, generally speaking, y'all, will start down here and go up, down, up, down, up. Real ugly, I know. Don't do that. I know it's so ugly. Let me try again. Suppose you didn't have to do it like. You know, shame my quintic function. Don't shame my, that is polynomial shaming, and that is not okay.
No.
There's no place for hate here, all right? You hating on my polynomial. That's all right. No place for hate. All right. All right. Okay. Whew. It's a little better, right? Okay, thank you. May I proceed? A little rusty kids. All right, so let's take a look at these. I actually want y'all to do, yeah, we're just gonna do ugly graphs for now. And we'll look at specific examples. So let's knock these out. What time is it? Go ahead and do these on your own, please. Real quick, remember, leading coefficient, highest degree, and in behavior statement. Y'all please use a pencil when you're doing these, please. That is the complete opposite of a pencil. Opposite of a pencil. That's a rough sketch.
Do some work. Yeah.
Mm-mm. That is your Delta math that I just passed out.
Yeah, we don't get no more death, man.
That I didn't say that. I ain't say that. It's been a week, pal. Say again. Not now that this was before March, whatever day that was. No, not yet. You ain't slick. Man, you a tripper, girl. Girl said she gonna do her Delta math. Mm. Can we talk about it real quick? All right, come on, y'all, because I got one more thing I want to talk about today. First one? Okay. First one. All right. Leading coefficient. Now we can call it LC, right? Because we know what we're talking about. Leading coefficient is what? 2, and it's positive. Okay. Oh, thank you, baby. I say, okay. All right. Leading coefficient is 2, and it's positive. And my highest degree is 5, and it is odd. Say again. What the devil? I pressed it twice. Bless the teacher. Okay. All right. 5, and it is odd. All right. So now I know exactly what I need to be looking at. I need to be looking at quadrant 1, don't I? Leading coefficient is positive. My highest degree is odd. Okay. Now, the number of roots, okay, the number of roots that I'm going to have on my little ugly graph over here. I'm not going to do my end behavior yet. Let's draw the ugly graph. How many roots? How many this is theoretically, young people? How many times is this thing going to touch the x-axis? 5. 1, 2, 3, 4, 5. All right, cool. Is it going to start up or down? It's going to start down. So here we go. Okay. My end behavior statement, especially now that I have an illustration to follow, is as follows, y'all. As x approaches positive infinity, as x gets bigger and bigger and bigger, what is my function doing? My P of X is approaching infinity as well. Very good. And as X approaches negative infinity, okay, when it's going the other way, what is my function doing? It's going to negative infinity. Okay? Very good, young people. Next one. LC, my leading coefficient is -3. And what type of number is it? It is negative. Excuse me? It's negative, right? Okay. My degree, my highest degree is what? My highest degree is 2. Okay? And that is an even number. Okay? How many roots does this thing have? How many roots does this thing have? 2. How many roots does this thing have? Look at the highest degree, not the leading coefficient. Be careful, okay? Look at the highest degree. So that means it's going to cross theoretically now, y'all, okay? These are not exact graphs. It's going to cross my x-axis in 2 places, right? All right. And then write out even. Now, because it's negative, are both of my ends going to point up or down? Okay, down. Look at your section. Look at the, what is that, quadrant 4? Thank you, sugar baby. Okay, so my quadratic is going to look something like this. The last thing I want to talk to you all about today, last thing, Savage, is something called number of extrema. Okay, write that word down. Extrema. What does that word sound like? Extreme. Okay. Remember when we were finding the relative minimum and maximum values? Okay. What an extrema, when they ask you for the maximum number of extrema, what they're asking you for is theoretically, how many times will this thing turn? How many turns will this polynomial make? Okay. How many times will it switch directions? Okay. And the only rule you need to remember is this. When you have to figure out the maximum number of extrema, the maximum number of times your graph will turn, the maximum number of times your graph will change directions, look at your highest degree and subtract it by 1. Don't believe me, just watch. Watch this. My highest degree here is 5, right? Automatically, theoretically, I know that this graph is going to change directions 4 times. Count them with me. 1 change here, 2nd change here, 3rd change here, 4th change here. Because if it changed directions again, I would no longer be dealing with a quintic function, would I? Okay. I'm afraid to try to say it because you guys are gonna say something weird. It doesn't matter. I'm gonna move on. I'm gonna move on. No, because you all were acting up when Mr. Bright said something, so I'm gonna keep moving. Okay. But do y'all see that? Now, look at the second one. What was my highest degree here? 2. How many times should my graph change directions on my picture? What did I say? It's going to be how many? 1 less than your highest degree, right? So what's my highest degree? How many times should this thing change direction? Once. Look at the picture. How many times did it change direction? 1 time. Okay, let me go back. Remember the ugly, hold on. The ugly graph we drew right here? What was the highest degree? 4. How many times should that thing change directions? Let's count them. 1, 2, 3. You with it? Look at part B. What was the highest degree? 5. How many times should that thing change directions? Let's count them. 1, 2, 3, 4. Okay? Now tomorrow, young people, we are gonna focus on drawing not so ugly graphs. So we're gonna draw graphs that are a little bit more accurate, okay? I'm gonna go with accurate. You like your word exquisite, exquisitely drawn? I don't know if I'll ever give you exquisite, baby, but I'll give you accuracy though. Okay, can I give you accuracy and you give me exquisite graphs? Beautiful, love it. Did you just Vanna White your? I'm not doing this. All right, yes. Say again. What definition should you write down for extrema? Turning point, change direction. Okay. Peak, valley, local maximum, local minimum. They essentially mean the same thing. Okay.
But number of turns.
Number of turns, that works too. All right. Hey, hold on. Wait a minute. No, wait. All right, y'all listen. Y'all see that worksheet I just gave you? Everybody put it in your hand. Right now. Savage, Jamari, worksheet. Hey guys, you're being terribly disrespectful and I'm about to get angry because I'm addressing the whole class and you're being loud and you're ignoring your instructions. Okay? I don't want to hear your voice. Thank you. All right. Look at the front page. Look at the front page. I want you all to complete numbers 1 through 10. That's it. 1 through 10. That's it. Number of turns. Mr. Bright said it great. Number of turns. You need a what? Let me tell you something. Whatever the devil y'all were talking about back and forth. As long as somebody is, as long as everybody's health is good, it's not important. Do you hear me? Mm-hmm. You finna sit on my furniture and be on your phone? And where's the rest of your clothes? You got a jacket with you? Put it on, please.